tsunamis, pandemics, and climate change are becoming increasingly severe. Since the Industrial Revolution, humans have caused the Earth to warm at an alarming rate. Scientists estimate that by the end of this century, temperatures could rise by 1 to 3 degrees Celsius. Resources are depleting while the population continues to skyrocket. We clear forests for agriculture, and more than half of the oceans are overexploited. Polar ice is melting, and sea levels threaten to erase continents. All disasters could occur until humans can no longer inhabit this planet. So, where do you think we could live? Where is ideal for 8 billion people to coexist and breed? Of course, humanity will not stand still waiting for nature's judgment. Besides efforts to save our planet, humans have other plans. Since the day we ventured into space, humans have nurtured the dream of conquering other planets. In addition to exploring life on those planets, we researched to find a second home. A suitable place for humanity to settle and develop. Therefore, theoretical physicist Stephen Hawking believed that humanity needs to study space more. And to date, through our efforts, humans have discovered many planets that could potentially support life. Humans have also begun preparing for new explorations to set foot on other planets. Although this work is a long process, requiring a lot of time and money. For a planet to replace Earth, it must meet the following criteria. First, it must be a rocky planet. Rocky planets are composed of solid material and an enveloping atmosphere. This structure is similar to Earth's. The rocky surface would help humans build structures to support life on that planet's surface, while the atmosphere protects humans from radiation from stars. Second, the planet must have water. Water is an essential solvent for the development of life. Clearly, we cannot live on a dry planet when 75% of our bodies are water. A planet with water, especially liquid water, could be a place where life exists. Third, its atmosphere must be thick enough and contain oxygen for humans to breathe. And we have a few potential candidates. Closest to us are the planets in the solar system. There are 8 planets here. Among these, only 4 meet the condition of being rocky planets: Mercury, Venus, Earth, and Mars. Jupiter and Saturn are gas planets, while Uranus and Neptune are ice planets. It is very difficult for humans to set foot on the surfaces of gas planets. When entering the atmospheres of these giants, we would fall into dense gas clouds. Then, we would fall straight into the planet's core at about 176 kilometers per hour until crushed by pressure. Therefore, a planet with a solid surface is the first factor we seek for life to form. The first rocky planet is Mercury. But it is eliminated precisely because it is first, so Mercury is very close to the Sun. This causes its temperature to reach 430 degrees Celsius during the day. At night, we would experience cold near -200 degrees Celsius. Meanwhile, its mass is too small to retain an atmosphere. Its atmosphere continuously disperses into space until it is completely lost from the planet. Thus, if we went to Mercury, we could only survive for over a minute before vanishing. The next choices are the 2 planets adjacent to Earth. They're considered twin siblings to where we live. If Venus is considered Earth's twin sister, due to similar size, gravity, and orbital parameters, then Mars has ecological characteristics quite similar to Earth. If our planet were to perish, would you choose to live on Venus or Mars? Although it is the second planet in the solar system, Venus is the hottest planet, even hotter than Mercury. Its atmosphere is very thick, but 96.5% of its composition is CO2. This creates a greenhouse effect, causing the amount of heat it receives from the sun to be trapped inside the planet. The CO2 clouds reflect heat back into space, forming a giant glass layer surrounding the planet. The average temperature on this planet reaches 462 degrees Celsius, too harsh for any organisms on Earth. For these reasons, humans cannot survive even for a second on Venus. So Venus has been ruled out, but Mars is different. When it comes to extraterrestrial life, Mars is one of the top names searched for. Viewed from Earth, we see a planet covered in red, like the color of blood. Blood is often seen as a symbol of war. So people named Mars after the god of war in Roman mythology. Actually, the red color on Mars that we see is due to iron in the soil and rocks. On this planet, iron reacts with oxygen in the atmosphere to form iron-free oxide, similar to the rust we commonly see. Mars' atmosphere is quite thin, consisting of CO2, argon, nitrogen, and a little oxygen and water vapor. Therefore, although Mars' atmosphere is not very good, humans can feel comfortable on Mars for up to 24 hours. Compared to Earth, Mars is a frozen desert with an average temperature of about -62 degrees Celsius. Quite harsh, colder than the Arctic on Earth. And its dust storms can last from 2 weeks to several months. But humans still hold much hope for Mars. Why is that? Mars is a planet similar to Earth in many aspects. Although its diameter is only half that of Earth, Mars has a rotation period and axial tilt similar to Earth. A day on Mars lasts about 24.5 hours. But you know, what makes Mars most interesting is the belief in life on this planet. Even, some believe that a civilization of Martians once existed there. Scientists have found much evidence of the existence of liquid water on this planet. Having liquid water as a solvent means a high possibility of life existing. On its surface, there are traces of flows deeply carved into the soil and rocks. Mars might have been a wet planet with many rivers in the past, creating vast delta plains. But today, liquid water no longer exists on Mars. For some reason, it has evaporated from the planet's surface, leaving a barren planet with a red color of soil and rocks. However, water still exists on Mars. It's just not in liquid form, but exists as solid and hard ice blocks at the planet's 2 poles. If this ice layer melts, an ocean would cover the entire planet with a depth of 25 meters. Additionally, when drilling a small hole into Mars' surface, people see gray soil and rocks underneath. This soil and rock layer is not oxidized and may hide many interesting things about Mars. It could be organic matter or, more specifically, life. Moreover, Mars has many similarities with Earth, which has spurred new human advancements in space exploration. Although scientists have successfully launched unmanned probes to Mars to gather information, the speed at which these robots provide information is too slow compared to expectations. Scientists are still eager to send humans in the flesh to set foot on Mars and explore the planet more quickly. But unfortunately, since Neil Armstrong set foot on the moon in 1969, countries have no longer been enthusiastic in the space race to create groundbreaking events anymore. And landing on Mars with a manned spacecraft at this time is not yet possible. Some other celestial bodies are believed to have life in the solar system. Moon Europa and Saturn. After 12 flybys of Jupiter, the Galileo spacecraft captured images of Europa. From the images, Europa's surface is covered with a layer of ice. This ice layer is unusually smooth. Observing this ice layer, scientists noticed that, after breaking apart, it seems it can be pieced back together, like a puzzle. Beneath that ice layer could be mud or liquid water. This is quite similar to the seas in the polar regions on Earth. Scientists detected a mysterious magnetic field emanating from Europa's core, causing the ice layers to crack due to Jupiter's gravity, and a force emanating from beneath the icy crust. Therefore, they researched and concluded that beneath that ice is salt water. Salt water can generate electric charge, and where there's water, life could potentially exist. Although currently, we haven't found life on Europa or not. But if there is, life on Europa would be adapted to that planet's organisms. Anyway, Europa is too cold for humans, and living on such an ice layer is not at all comfortable. Titan is the second largest natural satellite in the solar system. It can be said that this satellite has many similarities with Earth. Despite the frigid temperatures, Titan also has valleys and dunes. Because it is far from the Sun, it only receives about 1% of the light compared to Earth. Like Earth, Titan has water, with many lakes and oceans appearing on its surface. The water on Titan does not have the H2O molecular structure like on Earth. It is liquid methane and ethane at a temperature of -179 degrees Celsius. The lakes discovered are giant methane lakes beneath Titan's surface. Methane in the atmosphere plays a similar role to water in Earth's atmosphere. Additionally, Titan's atmosphere also contains organic compounds. This suggests that this giant moon may harbor many interesting biological compounds, such as amino acids, the building blocks of all living organisms. That could be the origin of life on this satellite. But like Europa, Titan is too cold. If we want to live on Titan, perhaps we have to wait 5 billion years from now, when the sun becomes a red giant star. The sun will expand due to helium burning. It will expand so much that it engulfs Mercury, Venus, and even Earth. At that time, the distance from the sun to Titan will shorten and Titan will gradually warm up. That could be our time, similar to Earth 3.8 billion years ago. Although we haven't found any place more promising than Mars. But human aspirations have never had limits. Humanity has wanted to venture beyond the solar system. Scientists observe the stars closest to the solar system, which is the Alpha Centauri star system. This star system consists of 3 stars, Alpha Centauri A, Alpha Centauri B, and finally the red dwarf Alpha Centauri C. The 2 stars Alpha Centauri A and B are similar to the Sun. But the red dwarf Alpha Centauri C is more special. It has 2 orbiting planets, one of which has characteristics similar to Earth. In 2016, the European Space Research Organization in the Southern Hemisphere discovered an Earth-like planet called Proxima Centauri b. This planet orbits the red dwarf Alpha Centauri c and is considered Earth 2.0 because its surface is very similar. Moreover, this planet lies in a habitable zone of a star, similar to Earth's position in the solar system. It is not as hot as Mercury because this red dwarf has a lower temperature than the Sun, only about 1/10. Therefore, at that distance, Proxima Centauri b still receives warm heat. Like Earth receives from the Sun, and it also has liquid water. This is also a rocky planet with a mass about 1.27 times heavier than Earth. So finally, we have another option besides Mars. However, this planet has a locked orbit. So one side of it faces the red dwarf, very hot and cloudy. The other side has fewer clouds but is cold. This planet is too far from us. It takes 4.3 light years to get there. That is too long, and we haven't found a reasonable travel solution yet. Therefore, living on Mars is still the most feasible. They heard of Elon Musk. He once talked about the plan to send 1 million people to live on Mars by 2050. But this mission hasn't been carried out due to limited funding. According to estimates, NASA and ESA need a budget of about $4 billion or more to carry out the mission to send humans to Mars. Among them, sending robots to Mars has already cost $2.5 billion. If humans go to Mars, the cost is estimated to increase, possibly up to about $100 billion. The average estimated cost for human spaceflight activities after Apollo is about $350 billion. But we have only launched about 350 American astronauts into space, costing about $1 billion per person, so reducing costs is an important goal. Otherwise, we won't be able to go anywhere. And to send 8 billion people to Mars, the number is certainly unimaginable. So, first, humans need to research more about Mars. Solve the problems related to cost and technology. To get astronauts to set foot on that planet's surface, then have a solution for them to return to Earth. Previously, sending rovers to Mars was much easier because they didn't have to return to Earth. Problems like food and water are not as complicated as for humans. We have to fly at least 6 months to reach Mars. During the journey, in outer space, challenges like solar storms, radiation, and billions of other problems are also very difficult. Scientists have designed models simulating human life on Mars in the Utah Desert, USA. As soon as the plan to send humans to Mars succeeds, These models will be applied to build human habitats. Do you think this plan is feasible? Will Earth remain stable long enough for these things to become reality?